Okay, today's notes are on systems of inequalities, word problems. Go ahead and jot this down. We're going to go ahead and get those words up on the top. And then on the bottom, we should have an extra piece of paper that has all these. If not, you can go ahead and copy this down at your leisure. I'm just going to go ahead and get started because, again, you can pause this video whenever you want. So these are going to be some key words that we're going to be focused on. Anything that sounds like this where it has greater than, more than, larger than, or above, we're going to be using this symbol. And anything that says greater than or equal to, no less than, at least, or minimum of, we're going to be using the greater than or equal to symbol. If it sounds like smaller than, less than, fewer than, or below, we're going to be using the less than symbol. And then finally, if you have a less than or equal to, no more than, at most, or a maximum of, you're going to be using this symbol right here. So we're basically going to be using everything that we've learned up until this point for the last 6 topics, I believe. And we're all going to kind of like mesh them all together. Okay, so let's see how this works. It says Catherine works no more than 20 hours each week. Babysitting earns her $8 an hour. Working as a hostess earns her $10 per hour. She needs to earn at least $180 each week to save for the car she wants. Write and solve a system of linear inequalities that displays all possible combinations of hours she could work at each job to reach her goal. So, like always, first we're going to identify the variables. Now, the only thing I don't like about the way they have this set up is they're making you use X and Y. Usually we would pick our own variables, but they're going to make us use X and Y. That's okay. Again, what is it that I don't know? Now, during class, I heard a lot of kids say, like, oh, we don't know the number of hours. Remember, we have to be very specific because I do know that Catherine wants to work no more than 20 hours. And while not knowing the number of hours is close, it's not close enough, okay? What I don't know is how many hours she's going to work as a babysitter as opposed to how many hours she's going to work as a hostess. So I do know the number of hours. I just don't know the number of hours, like in what job, right? So I'm going to go ahead and start off by saying let X represent the number of hours as a babysitter. And similarly, we're going to let Y represent the number of hours worked as a hostess. All right, so there's our variables. I have my X defined, I have my Y defined. Now, this is going to be probably the hardest part is I want to write a system of inequalities, right? So essentially, there's two different things going on here. They are giving me information about the number of hours, and then they're giving me information about money. And I definitely want to keep those two separated, okay? I don't want to intermingle them. So what does it say? It says Catherine works no more than 20 hours each week. I don't know how many of those hours are babysitter hours, and I don't know how many hours of those are hostess hours, but I do know that collectively, or when I put those number of hours together, it's going to be no more than 20 hours each week. So let me go ahead and put those hours together. Remember, X represent the number of hours as a babysitter. So I'm going to take the number of hours as a babysitter, X, plus the number of hours as a hostess, Y. That's me putting the 2 hours together. And I want it to be no more. Well, when they say they want it no more than, that sounds like this, which means I want that quantity to be less than or equal to, and in this case, it said no more than 20 hours. So this needs to be less than or equal to 20. There's my first inequality. Let me go ahead and start my second inequality. That first inequality only talked about hours, okay? This one I want to write as it pertains to money. What did they tell me about the money? They said that she earns $8 an hour babysitting, and she earns $10 per hour as a hostess, and that she wanted to earn at least $180. Okay, so let's go ahead and talk about what's going on. $8 an hour as a babysitter. Remember, babysitter was X. And we've done this before. So if I want $8 an hour as a babysitter, that is 8X plus. And she's getting $10 as a hostess per hour. So that's going to be 10Y. And in this case, they said that she wanted to earn at least $180. When they say at least 180, that's this word at least, which means I'm going to be using the greater than or equal to symbol. I want this money to be at least 180. Okay, so we did the hard part. We set up our variables and we set up our inequalities. The next thing I need to do is graph the system. Unfortunately, I cannot graph this right now because remember, in order for me to graph, I need to make it look like y equals mx plus b, which means I need to isolate that y. And right now that y is not isolated, it's being added by x. To get rid of that, let me go ahead and write that inequality here. X plus y is less than or equal to 20. Remember, we're going to try to isolate the x, which means I'm going to subtract x on each side. And when I do that, I get y is less than or equal to negative x plus 20. Now that the y is isolated, now I know how to graph it. I'm going to go ahead and start at 20. Remember that if it's negative x, that means I am going to go down one, right one, down one, right one, down one, right one. Now, ideally, if I wanted to go down one, right one, see how these are counting by 2, 16, 18, 20? Down one, right one would be down one, right one, and I would put a dot right here. And then if I did it again, I'd go down one, right one, and I would put a dot right here. Instead of me going down one, right one, I'm going to do something a little bit different. I'm actually going to go down to right 2. Just understand that that's the exact same thing, because if I divide the top and bottom by 2, if I simplify that fraction, it still becomes negative 1 over 1. Why am I doing down 2, right 2? Well, because it's going to be easier for me to go down 2, right 2, put a dot, down 2, right 2, put a dot, okay? So down 1, right 1, down 1, right 1, down 1, right 1, but really it's the same thing as going down 2, right 2, down 2, right 2, down 2, right 2. And if I do this, I get a dots that go all the way through like this. The next thing I got to ask myself is, do I draw a solid line or a dashed line? Because this has an equal sign, I'm going to be using a solid line in this case. And then finally, I got to figure out, do I want to shade the top or the bottom? Well, this says less than, which means I need low numbers, which means I want to be shading this area down here. So I'm going to take my highlighter. Let me go ahead and take blue. And give me 1 second. Oh, I guess that's as high as I can go. Okay. Hey, one of the tricks, especially on this problem, we're going to want to highlight the line itself and then highlight everything below that line. I know for this, you're like, who cares? I can go ahead and highlight, however the heck I want, just as long as it's in the bottom. And while that's true, when the lines get really close to each other, it does get a little confusing as to which side to highlight. So I like highlighting the line first and then deciding which side I want to highlight afterwards. And you'll see why that's important in a little bit. Excuse me, sorry about that. Okay, same thing with this one. I want to graph this, but I can't because the y is not isolated. So let me go ahead and start solving for it. I'm going to actually do it here. And let me go ahead and subtract 8x on each side. These are going to cancel. I get 10. Y is greater than or equal to negative 8x plus 180. And I'm going to divide both sides by 10. Hey, when I do this, I'm going to write the final one down here. I get y is greater than or equal to negative 8 over 10x plus 18. Now, I said I was going to leave it like that, but actually I'm not. That fraction does simplify, so let me write that fraction simplified. Y is greater than or equal to negative 4 over 5x plus 18. And now I'm going to go ahead and graph. Let's see. This says I'm going to start at 18. 18 is right here. It's really important I simplified because that's going to give me an extra dot. This is going to go down 4, right 5. So from here, I'm going to go down 4, right 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And put a dot. And I'm going to do it again. So down 4, 1, 2, 3, 4. 1, 2, 3, 4, 5. And put a dot. Now, I know some of you guys are thinking, wait a minute, shouldn't you be counting by 2? Guys, it's still going to work. Hopefully that made sense to you, but if it doesn't, let me show you why it still works. If I actually went down 4, it'd be 1, 2, 3, 4, and then right 5, 1, 2, 3, 4, 5, put a dot. And then I would do it again, right? So down 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. And sure enough, my dot ends up exactly where I said it was going to end up. So going down 4, right 5 is the exact same thing as going down 8, right 10. Okay. I'm not changing anything. So let's see. Let's go ahead and draw a solid line this time because again, it has an equal sign underneath. And if I draw a straight line, it looks like this. Now, this is where I was saying earlier, like it really, really matters how you shade this thing because the lines are so close, it's very easy to get confused. Remember that my line is this line right here. I need to shade this line, and because it's a greater than, I need to shade the stuff above, all of the stuff above. Be careful not to accidentally cross over to the wrong side, okay? So remember, we're starting with this line here. So let me go ahead and start by shading that full line and everything above it. So here's the line, and I'm shading just above that straight line. And everything above it gets shaded. So it looks like I'm shading almost everything got shaded on one end or another. Sorry guys, this is as big as I can shade. Like I can't. It's gonna take me a while. Hopefully your shading will be a little bit fast, or maybe this is giving you some chances to catch up a little bit. Anyways, this is what ends up being shaded. Now I want you to notice that's a lot of shading, right? But where is my answers at? Remember, your answers are going to be anywhere that got shaded twice. This only got shaded in blue, it is not an answer. This only got shaded in red, it is not an answer. Anything in here didn't get shaded at all. My answers are going to be just this little section right here, like this tiny little skinny triangle. And because both lines are solid, any point on those triangles technically are shaded twice. You guys have done an excellent job of understanding that concept. So I'm going to find two possible combinations. Remember, I'm looking for anything inside this triangle, including the dots on the thing. Because the line is solid. So this point is actually going to work. What point is that? That's 6 comma 14. 6 comma 14 is a solution. This point would work as well. I don't mean to pick the points on the line. It's just that there's not really many options. So 8 comma 12 would be another one that works well. Remember that this is your X and your Y, and your X represented the number of hours as a babysitter, and Y represented the number of hours as a hostess. So if this person wanted to work no more than 20 hours and still earn at least 180 bucks, she definitely could work 6 hours as a babysitter and 14 hours as a hostess, still be within the 20-hour mark, and still make at least $180. Okay. All right. That takes care of the first one. Let's go ahead and go down to the last one. I'm going to go ahead and read through the problem. It says Clay sells chips and sodas at a concession stand. He makes 50 cents profit on every bag of chips he sells and $1 profit on every soda he sells. He wants to sell at least 35 items and earn at least $30 every time he opens the concession stand. Write and solve a system of linear inequalities that shows all possible combinations of the number of sodas and chips he could sell to reach his goal. So one of the hard parts is going to be, what do I let X and Y represent? So what don't I know? I know how much money he's trying to make, so that's not a mystery. What I don't know is how many chips and how many sodas he's going to sell. So let me go ahead and start off by writing, let X represent the number of, and let's do it in the same order they did it, the number of chips he sold, and let Y represent the number of sodas he sold. So now I know X represents the chips and Y represent the sodas. We're going to go ahead and start setting up our inequalities. Again, as far as what do I know he wants to sell at least 35 items. Well, those 35 items, some of them have to be chips and some of them have to be sodas. That's going to be very similar to what we did earlier. So I'm going to go ahead and write, when I take the number of chips plus the number of sodas, that's going to be at least 35 items. That's what it says right here. And when I say at least is this one right here. Whoops, did not mean to do that. Let's try this again. At least is this symbol right here. So I'm going to write is greater than or equal to. 35. That takes care of my first inequality. Let's take a look at the second inequality. The second inequality, all I want to do is talk about money. It says he makes 50 cents profit on every bag of chips, and he makes $1 profit on every bag of soda. So for the bag of chips, he makes 50 cents for every bag of chips. That should be 50 cents X plus $1 for every soda. So that soda is represented with Y. So there's my money. What else did it say? It said that he wanted to make at least $30. Hey, they're using that word at least again. That means I'm going to be going with the same symbol. And I want it to be at least 30. Okay. All right, same thing as before. I'm going to graph the system. Unfortunately, I cannot graph these because they're not in the right form. I'm going to put it in the right form. That's going to be x plus y is greater than or equal to 35. I'm going to subtract x on each side. I'm going to get y is greater than or equal to negative x plus 35. Now, it is in the correct form, and I can go ahead and start graphing. I'm going to start at 35. It's right here. My slope says go down one, right one, down one, right one, down one, right one. Well, in this case, they're counting by fives. Remember that down one, right one is the same thing as down 5, right 5. Okay, you have the exact same fraction. So down 5, right 5, put a dot, down 5, right 5, put a dot, and we're going to go all the way through. Looking ahead as I'm putting in these dots, because there is an equal sign down here, this is going to be a solid line. Unfortunately, they did not get creative on these ones, but on your homework problems, they will definitely have some dashed lines when there is no equal sign down there. And it says I want it to be greater than. So that means I need the big numbers, which means I need a shade up here. So just like last time, I'm going to go ahead and shade the line first, just so I know where to start. Oops, I don't know what happened there. Just so I know where to start. And then everything above that is going to get shaded. I don't know what happened there, guys. You guys got to see my library. Let's try that again. I'm not going to do the greatest job shading here. Hopefully you do better. Fortunately, my stylus is not great for doing a bunch of shading. All right, there's the first one. Let's go ahead and work on the second one. Just like last time, this is not set up for graphing, so let me go ahead and start solving it here. I'm going to subtract 50 cents x on each side. These are going to cancel. And I don't want to write 1y. I'm just going to write y is greater than or equal to negative 0.50 cents x plus 30. Now, I would love to write that here, except I don't like that 50 cents. Remember that negative 50 cents, that's the same thing as negative 1/2. So I'm going to write this as y is greater than or equal to negative 1/2 x plus 30. That's going to make it way easier for me to graph because now I know I'm going to start at 30. And I'm going to go down one, right two. Now, when I say down one, right two, just understand that down one, right two is the same thing as down 5, right 10. They're the exact same thing. So I'm going to go down 5, right 10, put a dot, down 5, right 10, put a dot, down 1, right 2, down 1, right 2, down 1, right 2. We're going to go ahead and connect this line. This needs to be solid because, again, it is dashed. And oh my gosh, look at all that shading I got to do again. So hopefully my playlist doesn't pop up again. Again, we're going to highlight the line first. And then I want to shade everything above that line. So I'm going to go all of this up top. Everything that got shaded twice is where my solutions are going to be. And guess what? I got a ton of solutions. Now, last time we picked stuff on the line because I really didn't have any options. But if you can, if they're asking for, pick easy ones. Like, look at this one right here. That's definitely something that got shaded twice. What answer is that? That's 25, 30. Don't pick stuff that's like on the line if you can avoid it, okay? That's definitely going to work. And let's pick another one that's shaded twice. Let's pick this one. Oops, sorry. Give me 1 second. My iPad's going a little crazy here. I can fix it though. There you go. Let's pick this dot right here. And what point is that? That's 15 comma 45. That's another solution here. And remember, what did this mean? Well, this is my x and this is my y. And we said that x was the number of chips and y was the number of sodas. So if he wants to sell at least 30 items, well, yeah, he can definitely sell 15 chips with 45 sodas, and he'll definitely make more than, what was his goal? $30? $30. All right, that's all the notes for today. As always, if you ever have any questions, please feel free to ask.